Welcome back to CCNA 2. So we're going to talk about basic router configurations. Now most of this is going to be pretty basic reviews, so I'm not going to stay and get into a bunch of details here. I'm just going to kind of skim through it and try to give you some good information if you're reviewing to try to make sure that you're up to speed here. Of course, Cisco routers and switches are very similar. They're very similar, and this is really important. So when Cisco acquired the Catalyst brand of switches, they were very different. And so since then, they have made the iOS on switches and routers very similar. It works very similar. It's pretty awesome. There's only a few vendors that do that kind of similarities any better. I've seen quite a few vendors that their router software and their switching software is completely different, and it's like learning two different platforms, which is really annoying. Cisco, 90% of it's the same. There's only a little bit of difference between routers and switches when you log into them, configure them. So I very much value that from Cisco. So a lot of these commands, configure terminal, exactly the same on switches, and we've been over this stuff before, right? Hostname R1, right? Just setting a host name. Enable secret, right? Where this is our enable password, so we type in the enable command. When we're in non-privileged mode, to get into privileged mode, it should be, I'm sorry, wrong symbol there. It should be a less than or more than symbol, excuse me. Secret means it's an encrypted password. And then class is the actual password. Line con 0, right? So we're dealing with the console physical interface to log into the switch. We're setting a password on it. Very good practice. We want to set a password there. Log in, because we have to have that login command to prompt for a password. We're going to jump out of that. We're going to jump into the virtual terminal lines. And if you remember from our last session, we talked about different ways to remotely log in via the virtual terminal lines. So think about it for a second. Which way are we allowing to log in this? With just a password, no username, and just log in, not logging local. So think about what kind of remote login will be activated by this configuration. Then of course we're going to jump out and we're going to enable password encryption. This does not make your passwords 100% secure. It only keeps people from looking over your shoulder and easily guessing your password. If they do have your config and they have these encrypted passwords, they can decrypt them, but it's an extra step, which, you know, if your password is I love honey bunches of oats, then they can't just look over your screen and remember that. It's going to be a bunch of scrambled garbage, and they're going to not be able to really remember that as a human being very easily. So, better than nothing, but definitely not foolproof. Of course, we have banners for legal notifications and stuff like that. And of course, we want to make sure we save our configuration, just like on a switch. We also have the super secret WR command we can't tell anyone about because it's secret. But those commands are identical on switches and routers. One of the really distinguishing features on routers is the kind of interfaces we can use. One of the cool things we can do with routers is we can actually run dual stack. So that means that we can run IPv4 and IPv6 on the same interfaces. We can do that. You'll see the number on top here is a dot number. So that means it's IPv4, the double colons, it's IPv6, running on the same interface. We can do that too on switches. Really cool stuff. You don't see as much on switches. You see a lot more on routers because they're the ones doing the actual IP traffic. So the router interfaces that are going to be different are usually going to be on these HWICs, these high-speed interface WAN cards, or WAN interface cards, excuse me. We'll have stuff like serial, which you probably should be used to. If you're not, go and look up pictures. If you haven't been in a lab, if you haven't seen physical equipment, go look at pictures on the internet. You can go find some HWIC cards with serial or something on that, just to have an idea what they look like. You can also have DSL cards and cable interface cards, the same HWIC slot. Think of it like a universal, like a USB port actually, as a good example, because you can have really any kind of interface. You can actually put switch interfaces as well if you want a switch, like maybe a 4-port switch on your router. Very uncommon, but you can. So to be available, we have to configure with at least one IP address. Now that can be IPv4 or IPv6. I underline them backwards, but IPv6 or IPv4, it doesn't matter depending on whatever technologies you're using. If you're using all IPv6 today, then of course you need an IPv6 address on your router. If you're using all IPv4, obviously you need IPv4. Otherwise, you can run both, either, depending on your situation. We have to activate our router interfaces. A very important distinction. Switches by default, their interfaces are turned on. They're all enabled by default. Routers, however, are not. So we need to make sure we have this no shutdown command in there. We want to make sure, a lot of times I forget it, students forget it, other people in the industry forget it. I've seen people forget the no shutdown command on their CCNA, and they were just totally disappointed in themselves. So just, even if you put it in twice, it doesn't matter. Better than forgetting it. So try to remember that no shutdown command. We also have these optional descriptions, and those are going to give us some beneficial information. So maybe you can go in there and say, hey, this is a connection to blank, or this is the really weird interface that goes down all the time because of a service provider issue, or whatever kind of useful information you want to put in there. You have 240 characters to do it, which if you're putting 240 characters in your interface descriptions, please stop. But there is a lot of room there for you to put some information in there if you need to. Usually, from what I see in the industry, the descriptions are pretty brief, pretty straight to the point, and can be very, very useful sometimes. You know, marking something as a particular odd device, or a particular reason it's an odd VLAN or something like that can be very, very useful on switches, more than routers, but either way, a simple way of documenting a network to a point. So here's some examples of interface configs, right? Descriptions, no shutdown, IPv4 and IPv6 addresses, stuff like that. Should be all pretty straightforward and familiar to you guys. Another thing is loopbacks, so you can configure them, interface, loopback, and then make up a number. They're virtual interfaces. Think of them kind of like a switch virtual interface we talked about. So just think of them as kind of inside the router. So really it's just a virtual interface inside the router. We can assign an IP address to if we want. Now by default, they're in an upstate as opposed to normal interfaces on a router being in a downstate by default. Other than that, they pretty much are used for testing or maybe internal routing processes. I've seen them used to do some kind of weird BGP stuff in the past, and we're not going to get into that in this course, but just keep in mind there may be some odd use cases, but most of the time it's used for test environments, lab environment type stuff. So pretty straightforward. With that, we're going to talk about 1.5 in the next section here, and then we'll wrap up Module 1. I'll see you then.